are the reciprocals of cosine and sine. So secant goes with cosine, cosecant goes with sine. So trying to remember, S goes with C, as much as that's confusing.
That didn't work. No, there's C.
The first letter. The first letter.
What if you can't see?
I don't like this class.
Sorry.
Second.
Okay.
Second.
So, all right. What we're gonna see here is that we're gonna use sine to graph cosecant and secant to graph cosine. So.
Have you ever wondered why people spell things the way they do? Like why is the rest? Have you ever wondered? Yeah, but like PH, like for what reason?
Right. I don't know.
Someone.
Okay. Guys. Okay. So, in order to graph cosecant, we have to graph sine first. So, I'm going to actually, again, and you don't have to pull up decimals. I'll pull it up for us if you want to take your time, but
You got it, bro?
I want to show you guys how this graph looks.
Decimal. Oh.
You pull up decimals too?
Okay.
No, man.
No. Okay. So there's our sine of x, and I want to graph cosecant so you guys can see how this looks. So sine is in the red. Hold on.
That's not
Oh my god.
Bro.
That's not a use.
You're done.
You're done. Alright.
Well, that's not. That's weird.
Alright. So let's take a minute to look at this and try to see kind of what's going on here. So again, the red is the sine graph. The cosecant is the blues. Now you might wonder, where do they connect? They don't. These are all a bunch of different like parabolas. Are like little parabolas.
Wait, so they're not
That's
crazy,
man.
That's whack.
It's like the heaters in your grandma's house.
Oh yeah, it does.
It's like
Okay, so a radiator, yes.
Oh.
Yeah.
radiator springs.
Okay, so but hopefully you notice there's a very strong connection between sine and cosecant. So what essentially happens is at the maximum and the minimum points for all these sines, a cosecant, like a U, is drawn at the top of them. Now, or the bottom, I guess. So one of the things that basically is happening here is this is the complete opposite of sine. So as inverse as we can get, complete opposite. So it's going that exact opposite direction at those spots. Now, one of the things that happens is when sine is 0, when sine equals 0, guys, I really need you guys to focus, please. So, like, we need to stop the conversations, but when sine is 0, so like negative pi sine is 0, what happens with cosecant, we flip that fraction over and 0 ends up in the denominator. So the reason why these don't touch is these are asymptotes here, that those lines, like, and I don't know if we talked about that in this class, I think it was in pre-calc, so I get my math classes mixed up a little bit, but the idea is that it doesn't exist on this line. So cosecant doesn't exist on this vertical line because it's undefined. So that's why these u's exist. It goes around because there's no other place for it to go. So we draw these u's on the top and the bottom of our sine graph. Now this doesn't need to be a perfect science, but getting the sine graph down first is going to be super important because then we're just going to draw our cosecant on top of that. So if I have my sine graph drawn first, the amplitude and everything with the sine graph still applies here. So we're still going to use A and 2 pi over B for my sine graph. Technically, that all goes with sine. Cosecant, what we're going to do then is we're going to draw in anywhere you see the maximum point, we're gonna draw like a U here. Now, if you're wondering how wide to make that, you can kind of set little boundary lines if you'd like to. I'll write those in a lighter color so you're not, that's hopefully not too light. So when x is 0, or when the sine equals 0, I'm going to draw like a vertical line. That's like our boundary line. That's probably really hard to see, but I'm trying to make it not too dark.
And it's okay.
So I'm drawing these boundary lines. They're like a divider. Think of it as like a fence. And what I'm going to do is, again, on the top and the bottom of those, that's where my cosecant graph is going to come in. So if you're good at drawing sine, cosecant's kind of, it just goes with it. It's just like an add-on, bonus level. Now technically we don't need the sine graph there, but it's really it's nice to have it. So I'm going to tell you guys, just like we did with our shifts, it's fine if you want to draw the sine in, and again, if you want to use different colors, like use a lighter color, and then the cosecant should be like, it should be clear that that's what you're trying to graph is your cosecant. All right, so flipping it over, now, so cosecant and sine go together. So if we're trying to graph secant, what do you think we're going to graph first? We're going to graph cosine. So in order to figure out the secant, we're going to graph cosine first. And again, I could show this to you, but it just like moves over just like slightly, so it's not that much different. So again, amplitude, I'll still go with our cosine. But now again, when cosine equals 0, we're going to draw those vertical lines, those divider lines. So anytime the cosine equals 0, oh, that wasn't even the right spot. And then we're going to basically draw those U's on the top. So that's same idea. But obviously, if you're not good at drawing cosine or sine, these get a lot tougher. Alright, so we're gonna, so our first example there, it says 3 times cosecant of 2x. So again, kind of like when you're translating, when you're first learning a language, maybe you just translate it back to the language you're comfortable with. So let's just like, when we're talking about degrees and radians, let's translate this back to what we're used to. So let's translate cosecant. I'm gonna graph y equals 3 times the sine of 2x first. I'm going to set that as like my groundwork, kind of like laying out my plan here, because I need that for my cosecant. So I'm not just going to go ahead and try to figure out the cosecant first. So my amplitude in this case is 3. The b value is 2, which means my period then is pi. Yeah, it's a sine bx. Kind of like a y equals mx plus b. It's always in those same spots. So we're going to graph this, and I'm going to use dotted lines to do that. But we have to determine our scale first. What do you guys want to do for our lines? Are you doing fourths? Yeah. So I'm going to call that pi and then this 2 pi. And again, I think tonight's homework is the one where it gives you the scale. And again, if that's confusing, you can always give you just regular, they give you the scale on the graphs today. Hopefully that's going to be helpful. But I think I do one like that with you guys so you can see it. Yeah. So we're going to graph this again with dotted lines because this is not my actual graph. This is just the groundwork for it. But if I start at 0, end at 0, because I'm talking about sine, middle should be 0. I'm going up to 3, down to -3. And I don't know, this one might be a better one to kind of keep going as well. Just so I get a few more in there. So remembering the sign, and we're multiplying this by 3, that tells us like all our main points. But now for cosecant, anywhere the graph hits 0, if you want to draw those divider lines, you can. Otherwise, kind of cool thing is there's already divider lines there for you. So basically between these two, I'm not going to like let my cosecant go over those lines. So I'm just going to draw in here between those two to my boundary lines there, here. And no judgment on like, I mean, if you're going all over the place, like your U like is huge, then I guess judgments. I guess I shouldn't say no judgment at all. But trying to like kind of fit within there, it's okay if they're a little lopsided or. Yeah,
Why is Elmo on fire?
that was from Ari, her freshman year. Actually, I think she gave it to Lola, and then Lola like didn't want it and just left it here. So I just put it up. There was like a meme I think for a while. It was but that was their freshman year. So the seniors' freshman year.
That sucks.
You think you are until.
We're almost done.
Miss Donkey's first year teaching.
Yeah.
She's like a product, like painting a sign.
Oh.
Like,
She's
like,
in the Yeah, Miss Donkey, how do you feel that your first years are gonna graduate?
It's pretty crazy. They're a little bit.
Yes,
it's a little like.
You better cry.
Really?
do you guys listen to graduation night?
I don't really like it.
I tried to, I'm not a huge crier at the time. I usually cry like, or like something sets, I mean, I don't
Right
know.
on the first day of school.
Yeah, when I realized you're not back.
The new freshman class comes in, you just start crying.
You might.
She hates it.
Is it Griffin in that class? Or
He is
is
such a
He's
strong
the next one.
word.
He's the seventh.
Exactly.
No.
So yeah, that grade routine,
Yeah, they're gonna be like.
they're not gonna know what's happening.
It's a strong word.
She's gonna need to,
Strong, man.
after we graduate.
I'm weak.
I would sell it.
In there.
Luke, are you a little man, baby?
Okay. So again, I'm gonna translate this back into a language that I'm more comfortable with, and that would be cosine versus the secant. So again, translate it into a different language. Think about S becomes a C. So secant and cosine go together. Hopefully remembering those two. Thank goodness for a note card.
Oh no.
Alright. So our amplitude in this case is 2. The B value in this one is going to be 1. So that means the period is just going to be 2 pi. So that doesn't change at all. But this one needs to shift.
To the right.
The minus the, and there's something added or subtracted after. So we're going to go right pi over 3.
So if it's a minus, it goes right. If it's a plus, it goes left.
If it's inside within the city.
Yes. If it's outside, it's up or down. We'll do one of those in a second. Alright, pi over 3 might be oh no, it's not too bad, right? So I would just do pi over 3s for my scale.
Okay.
So then this would be pi. So then that means this would be 2 pi to get to my full curve. But I need to shift. So we're gonna I might try to do 2 things at once here, get a little crazy. Now remember our cosine starts at 1. And we have to multiply by 2. So, it should start up at 2, but I need to move it to the right pi over 3. So I'm actually going to start it right here. That makes sense? Yeah? So I was here, I moved it here. Then at pi over 2, I'm supposed to end it. So I'm going to shift that to the right 2, or right 1, sorry. At pi in the middle, I'm supposed to be down at -2. So again, I'm going to shift it to the right. Now the in-between, this is thirds, so this doesn't work quite as well. I'm just going to kind of go halfway between here and try to draw my dotted curve here. I'm trying to be a bone. Trying to figure out how far to go. Okay. So once I have my dotted, so again, the shift makes this even tougher, but now once I have my dotted lines here, I'm able to draw my actual secant graph. So, real lines here. And again, I just want to stay within where it hits 0. So I'm trying to stay before it, like, kind of a boundary line there. All right, we probably need a break, huh?
Yeah.
Oh,